here we go. So because today is pretty easy, I'm taking today to tell you about a few things. Like, for instance, this first test is about a week from today. It won't have calculators allowed on it, so that you'll have, that also means that you won't have anything gruesome. Like, we don't ask you to divide, 11 by 17 if you don't have a calculator. So let's do a little bit of review of some basic stuff that you should know by now. Like if I said, here's a Venn diagram with A is apples and B is bananas, could you please shade in for me not A intersect B? I'm going to put a box around this, and you should too. Shade in not A intersect B. The way I'd do it is I'd start by shading in not A. Then, with a separate color, I'd shade in B. And then I'd figure out if I want the union or the intersect of that. That was just from yesterday, and these are harder than you would think. A lot of kids struggle with it. So I'll get you started. Not A, you should have done this. It's like A is the sun, and I'm shading in everything that is not in A. There. Not A intersect B. Please get your final answer down and then erase everything else that shouldn't be there. And get it down to just shading in the answer. And then compare it to the kid next to you. In this case, don't forget to compare it to. Already done this problem. Compare it to these kids. Actually, yeah, in your case, did you guys already compare yet?
Yeah.
Okay, good. All right. Charlie, what did you get? Where would you say the answer is?
Shaded all of B, but not where A and B meet.
All right. So, when if you were going to describe it as, is it the blue striped area and the red striped area, or is it only places that are double shaded, or how would you describe it that way?
The blue striped area and the red striped area.
All right. So if I circle it here with yellow, is this the area that you think is the answer?
Yep.
All right. He is correct. Raise your hand if you had the same thing. Okay, good. All right. I think you've kind of gotten those. It can be tougher when there's a triple and when you do three things. So I'm going to do one more like that. Everybody make 3 circles. We'll call them A, B, and C to keep it super simple. And a box around the whole thing. And I'd like you to try not A intersect B union C, like that. Now, I've never written one that way, but don't parentheses get the top billing? Parentheses get priority? They do. So I would start over there with the B union C. And when you're done, compare with the kid next to you. I'll pause for a second. Okay, so that's a good question. One of the kids said, you don't have to actually find the exact answer, do you? All I said to do was factor. So if you factored it like this, that's all you had to do so far. X and X, and then you think of something that multiplies to -7. But I recommend you don't think about adding up to 6. Just focus on multiplies to -7. Well, -7 and +1 would do that. But then you check it with this. You don't check it with, do they add up to 6? Check it with this. And let's see, I end up with -6x. The reason this is more powerful is because in a minute, there's going to be a number like right there. And your whole multiplies to this and adds to that doesn't work anymore. So we don't want to do that. We want to check multiplying it all out in our head. And I got -6x. If you ever get the opposite of what you want, then you change to the opposite signs. You don't move the numbers, you change the signs. And there we go. X plus 7 and X minus 1, raise your hand if you had that one, right? What is the actual answer then? Well, X equals -7 and X equals 1. Those are the solutions. They're also known as the x-intercepts of the graph. They're also called the zeros, because if you stick them in, what do you think happens to the equation? It becomes equal to 0. Like, that's the whole point. It'll equal 0. Okay, cool. So, here's a more intense one. 2x squared plus 3x plus 1. Factor that one. Equals 0. And this time, actually give me the answers. So factor it and then use your factors to get the answer. Well, this is the kind that starts to trip people up. You had two parentheses, and then you're like, but I can't get the, so people get confused on what to do here. They know there's probably got to be x and an x. And then they're like, how do I split up the 2? You just pick one of them and make it a 2. 2x and x. Okay? Olivia, what do you know for sure about these two numbers?
That they're ones.
They multiply to 1 and therefore have to be 1s. In fact, there's only pluses, so they have to be positive ones. So I'm pretty sure I'm done. But you really have to check it. So what do I get when I do the outside, Olivia?
2x.
Yep. And what about the inside?
And then just x.
Yep. And when I put them together?
3x.
And that's what I wanted. Yay. So this time, that's not the answer. Sam, why is that not the answer?
You didn't find the roots of x.
All right. So what are the actual, also known as roots? Roots, that's intercepts, and solutions. What are they?
-1/2 and -1.
X equals -1/2 and x equals -1. And if you had trouble with where do you get that -1/2 so fast? He did this, and what you could do if you wanted to like just slow it down a bit is say 2x plus 1 equals 0, and then you solve that. Okay, now how could it be a little harder? Well, just imagine a world in which I changed this 2 to a 4. Imagine I changed this 3 to a 6. And I changed the 1 to a, what do you think I'm going to say? 2, because I just doubled all of them. Then what would you do? Yes, sir.
Take out, like, factor by 2 or whatever.
Factor out a 2, yes. You just factor out a 2, and then we'd have the problem we just had 2 seconds ago. A lot of people do get confused, though, that does this 2 that's on the outside then change the answers at all? No, it does not. It doesn't change the answers, okay? Why? Well, because if you make this equal to 0, 2 times the 0 is still 0. So that 2 out in the front, it really doesn't matter much. Okay, so let me give you one like that where you have to factor the most complicated kind. 6x squared plus 15x minus 36. You're like, that's crazy. I can't factor that. Once you figure out the common factor and you factor it out, it's not that bad. Now let's also say equals 0 so that we can get the zeros at the end after you factored it. Okay, talk to the person next to you. So Mira, what did you factor out at the beginning? 3, good. 12 times 3 is 36. That might have stretched a few of you. But then I got a set of parentheses that needs factoring. And let's go with Madeline. Can you do this? Okay, so you start with a 2x and an x. That's not that bad. So if you haven't already done that, do that. Now, we need a number here and a number here, and they have to multiply to negative 12. Can you give me some options you think might work? Negative 3 and 4. All right, so I'm going to go slap in a negative 3 here. Actually, I'm going to say a negative 4 and a positive 3. Why? Because I just want to show you it doesn't always work out super nice. Let me show you how I know for sure this is wrong right off the bat. The 2x minus 4 would have had something else factor out. Do you get how a 2 and a 4 have a 2 in common? So it can't be a 4. Why can't it be a 4 then? Because it would have factored out earlier. There would have been more factored out up front. So it can't be a 4 there. This is an advanced factoring trick, but it's true. This can't be something that factors with the other one. So if that's going to be a 3, then the other one can be a 4. And then you got to ask yourself, have I got it right? How do you tell? You go to the outside and the inside, and you get 8x minus 3x makes 5x. And look, that's what I wanted, 5x. Yay, I know I have it then. How many of you were able to find 2x minus 3 and x plus 4? Okay, awesome. All right. Unnamed guy, because your tag is flipped down. Can you put it back up? So like, there we go. Matthew, can you tell me what the final answers are there? An x equals what? An x equals what?
3 over 2 and negative 1.
Positive 3 over 2 and negative 4. You are correct. Any questions? All right. So as part of your homework for tonight, you have to answer one question like that. It's in a Schoology quiz. You also have one other old top 20 skill called midpoint. You want to just remind me quick, if it's 3 comma 4 and 6 comma 8, how do you find the midpoint of that? This is a key word, starts with an A, ends with an E. Say it if you know it. Average. You got to average the x's and average the y's. So how do you average 6 and 3? Yes. Good. So it makes it 9. 9 over 2, comma 8 and 4 makes 12. Divided by 2 is 6. Let's see how fast that is. Midpoint's super easy. All right. And there's one more mystery skill that you'll see. And those 3 are one-question quizzes. And if you bomb it, you can take it again. You'll be allowed to take it up to 3 times before I finally say, okay, well, you had 3 chances at it and you still don't know it. You clearly don't know it. Okay, so you get 3 chances to take one question. And as soon as you get it, you get 100% on it, then boop, you're done. So it's just kind of like a little checkup on your basics. So those 3 questions are in with your homework. What else is on your homework? Well, let's go look and see what's on today's docket. We're talking about top 20 as we just did. We're not taking a whole one. We're just doing some review. And we're going to talk about the Venn diagram lab. And the new thing for today is something called relations. So let's actually go talk about the lab for a minute. There is a folder in Schoology called Labs. It's purple. Go find the purple Labs folder and open up the thing called Venn diagram lab. It is the easiest lab. You're going to make a Venn diagram. You're going to poll some people, but I want to make you make it interesting to you. Like, for example, I am kind of obsessed with the future of what electronics and things are going to look like. I think electric cars are clearly coming on strong, and I think that There might even be robots in our future and not too long. And I think, like seriously, you might, when you're like my age, it might be common to have a household robot that you actually say, hey, robot, take out the trash, and it'll just be like, oh, okay, and it just does the work for you. Hey, robot, mow the lawn. Although I think you might have a separate robot for mowing your lawn, because you might not want your robot tromping around out in your grass, because frankly, even if you said somebody's gonna steal it, because they'd be worth a lot of money. It'd be like having your iPhone walk around your yard.
They're
Scared
only in
somebody
America,
to steal
though.
it. Oh, no, not just America. You might think America's the rich country.
Yeah.
We're not even the richest out there. There's a lot of rich people. There's more billionaires in China than there is in the United States. So there'll be a lot of people who will have personal robots. But there'll be a lot of people that don't.
I mean, lawn mowing robots like lawn mowing Roombas kind of already exist.
Exactly, I have one. I love it. Yep, it mows my lawn. We call it Mobot.
I have to mow mine.
I just put him out. He mows my lawn. It looks like a Roomba. So anyway, I'm kind of obsessed with the future like that. So like, and some of these things aren't even that like new. Like those lawn mowing robots, they're actually pretty big in Europe. They've sold many thousands even here in the United States.
I still have to mow my lawn, but I'm happy because they get money.
You get paid by mom and dad. I just had to do it. It was just a job because I had to earn some of my food, I guess. And I made my kids mow the lawn too. So anyway, moral of the story, I might be interested in a Venn diagram that's like, which will you be the most interested in buying? Would you, like, let's say I'm asking my friends, do you think that you will buy an electric vehicle? Do you think you will buy a robot? Or do you think you will be buying a Roomba? And some people might be like, well, I'm for sure going to get a Roomba. I already have one of those. I think I'm going to get an EV, but I don't think I'm going to get a robot. Well, then where would you be? If it was EV and Roomba, but not robot. Do you get I'm right there? EV and Roomba, but not robot. So then you'd go, okay, that kid says, yeah, I'll get an EV and a Roomba, but I won't get a robot. Then he's right here, and he counts as one. And then you just keep track of how many people. And then maybe you make tally marks like this, and eventually 5 people are in that category. 1 person's here, 3 people are here, 1's there, 1's there. So moral of the story, you're going to make, by doing a survey, you're going to make a, something that's interesting to you. I'm interested in this, you probably aren't. Maybe you're interested in how the world will end. Will it be robots take over the world? Will it be nuclear war? Will it just be a million years from now the sun expands so big that we all roast? Maybe you're not interested in that. Maybe you're interested in what's your favorite, I don't know, sitcom, or between these 3 things, would you rather watch Game of Thrones? Would you rather watch this or that? Anyway, so you're going to make a Venn, and you're going to ask people, and then here's the key. You're going to have to write 3 questions about it using symbols like intersect and union, and then describe what they mean. You can't just write, EV, intersect, Roomba, union, robot, and I got 2 hours here, so that was a bad plan. Anyway, I can't just say this. I have to also describe what this means in words. What does the question mean? And then what is the answer to my question? Okay, so the survey part, I'll take you, 10 minutes. Just make 3 circles, start asking people questions. You get all that part's easy. And then writing the question, you can write any question you want. Just make sure you understand what you wrote. Like if I don't know what intersect and union mean, I might not know what this even means. But if I can describe it in words like that means the place where people are going to like EVs and robots, but it's also the people who want a Roomba. I don't know. You just have to describe it in words. All right. So that lab, and all labs, have these key areas. You have to have a purpose. So in the lab, you must state the purpose of this lab is to blah, 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 blah. And to prevent you from just simply brainlessly copying what the directions say, you have to restate it in your own words. So one of the ways that you can get this wrong is to pretty much just say exactly what the directions said about the purpose. You have to rephrase it in your own words. Okay, so the purpose is what you're trying to do. All right, then next, you're going to have a graph for every single lab we ever do. Well, what would this graph be? Well, in this case, that is a graph, right? So sometimes it's a graph, we do a tennis ball lab where the graph looks like this and you're throwing the ball up in the air and how high it went and stuff. Sometimes the graph looks like that. Sometimes the graph is more of a table. But you have to have your data stored somewhere. And in the graph, I want to warn you, I always grade the labels. Always. So this, I would have lost points. Oh, wait, actually, no, I have a title across the top. Venn diagram's kind of lame, but I have a title and I have labeled each section. So that actually technically would qualify as everything's labeled. So just make sure you label your graph. Like this graph, I would mark it wrong because I don't know what this is and that is, and it always needs a title. All right. So every lab has a purpose, a graph, and then you have calculations, and you have procedure. The order doesn't really matter. I'm going to say procedure next. You need to write this one down because nobody knows what procedure means. Later when you're doing your lab, procedure means say in words what you did to solve. Versus calculations section. The calculation section is where you actually write out your equations. Like this is the calculation part. That looks like a math problem, and I'm going to actually solve it, and I get my answer, and let's say it's 6 people. Okay, that's a calculation. The procedures section, there's a whole section where you just say in words what I did. First thing I did is I polled my friends about whether they were more likely to buy an EV, a robot, or a Roomba. And then I wrote 3 problems, which I had to also explain. And so that's me explaining in words what I did. Calculations where you actually grind out the math. You actually show, here's the answers, and here's how I got them, and here's how I solved the equation. Okay? And the last thing, at the end of a little scientific study, who do you always have? A conclusion. And you'll always have reflections. That's where you say the conclusion was, most of my friends seem to be interested in all 3 things. Seems like my friends want to have an EV, they want to also have a robot someday, and they also think they're going to have a Roomba. It looks like all of these things are going to be popular. That would be a conclusion and a reflection upon the conclusion. One of your reflections, because you always have to have 3 reflections, it'll say that. 3 reflections. One of them can be a suggestion on how to make the lab better in the future. Think like a teacher and say, this lab kind of sucks because it didn't give us the freedom to do this. Or, I wish, if I were doing this lab, I would have done it this way. Okay, so that's going to be one of your reflections, is how to make the lab better. And then another thought about reflections, I will mark them wrong if they are vague, like, I used an equation. Come on, you got to be more specific. You can't just say, like, I saw math being used in the world. You could do that on every single lab. Too general. Okay, be specific about what did you learn here. Something you didn't know before, and now you know it. Okay? Yes?
What do you only have to have like
3 reflections. So for instance, on my lab, I just did my imaginary lab that was about this. I would say I am reflecting that it is interesting that it looks like all my friends are interested in all of these things. Okay, that would be one reflection. Reflection 2 might be, I wish that this lab allowed us to do 4 circles because I actually had this perfect problem that would have worked for 4 circles. So I wish it allowed us more flexibility. That would be a second reflection. Third reflection could be, I never have written up a lab report before. So this was somewhat interesting to me because I've never had a math lab in all my years. There's 3 reflections.
Okay, so there are
3 different things that you learned about, and it needs to be specific though. So no weak stuff like use math. Okay. All right, that's how labs work. Cool. Then the last thing I got to do is the actual new stuff for today, which let's do. It's pretty much a review of yesterday. That's why I had time to do all this other stuff. All right. Functions versus relations. All right, to teach this, I want to start with something like this. Would you agree that a quadrilateral means you'd have 4 sides? Remember that word? All right. Does a rectangle qualify as a quadrilateral? Yes. Does a square qualify as a quadrilateral? Yes. It's pretty easy to get into the four-sided club. There's a lot of things that have four sides. Okay, what's the ultimate picky four-sided shape? You have to have like all these rules, and then you can get into the four-sided special shape. What's that special shape that's got four sides? Square. Square is the hardest one. There's a lot of ways to make a rhombus. There's only one way to make a square. Okay, so square is the ultimate like hard club to get into. My point, functions is the hard thing to be. It's hard to be a function. It's easy to be a relation. Almost everything, not everything, but almost everything is a relation. All right, so like I can have a list of your height at the given moment and the price of gold in Switzerland. I can write your height and the price of gold in Switzerland, and then a couple days later I can check his height again and I can check the price of gold in Switzerland. They are two things. That's a relation. That doesn't mean that there's any correlation between those two things, and it isn't necessarily a function. But if you have any pairing of two things, that's a relation. Okay, so I can just give you a list of anything like 2, 3, 3, 7, and 3, 25. And as long as I have two things, that's a relation between two things, x's and y's. But functions are harder to be. It's a lot harder to be a function. So a function, you basically have, I'm going to show you on this set of points that I just made. All of the inputs can only have exactly one output. So, is this little thing, it's a relation. Pretty much everything's a relation. Is it a function? No, because which one screwed it up? The 3. When I put in 3, I should only get one consistent answer. So functions have to be consistent is a way to think of it. So think of it as a machine. Let's say somebody brought in a box of Kleenex, thank you very much. This person, I will leave names. Imagine though that this is a function, and I drop in a penny, and a quarter pops out. Well, dang, I like that machine. I could do that all day, turn pennies into quarters. Even if that fast, I could still make some pretty good money doing that. So I drop in a penny, I get a quarter, drop in a penny, and all of a sudden a dime pops out. Wait a minute, that's not a function.
Throws my little sister in.
You know what I
I'll
mean?
take the
I
chance.
still might be happy that I got my dime, but it wasn't consistent. Okay, so functions need to be consistent. So like say I put in a penny, I get a quarter. Let's say I put in a dime and I get $1. Put in another dime, I get another $1. Is that okay? I put in a dime, I got $1. Can I put in another dime and get another $1? Yeah, that's what I want to happen. I want it to be consistent. If I put in a dime, I always get $1. And then one time I put in a dime and I got a quarter. I can't predict it anymore. It's not a function. You get the difference there? When you put something in, you always get the same thing out. You get how when I put in a 3, I got a 7 here. When I put in a 3, I got a 25. Not consistent, not a function. All right. So some other words you need to learn. These are called the inputs. They're also called the domain. I'm going to write that down for you. The x's are the inputs, and they're also the domain of a function. Like that part. Then take a wild guess what the 8 would be like. It would be like y, and what else would be like? Output and range. Would this be a safe statement then? Any one input should have exactly one output. So let's pick an input. 2. What's its output right this second?
8.
Should that input have exactly one output? Yes. That's a function. If you have an input has exactly one output. Now this one messes with people. What if I put in 6 and I get 8? People feel like that's just wrong, but it's one input with one output. So far, that's legal. You can do that. All right, so this brings up like, oh man, now I'm getting confused. Like I didn't think that would be okay. Well, if I put in the same input though, like if I put in a 2 again, I better get an 8. Or if I put in a 6 again, I better get an 8. Okay? So a way to do this that isn't talking about inputs and outputs is, have you ever heard of the vertical line test? Okay, then I get to be the first to tell you about this. If I graph these two, would you guys graph 2, 8 and 6, 8? Would you graph those, please? Just put a dot where 2, 8 would be, and put a dot where 6, 8 would be. If it's hard for you to tell if the thing is a function or not, ask yourself if it passes the vertical line test. Can I draw a vertical line through this and have it on? See, this is an input. This is on my x-axis. That means my input was 2 and my output was 8. Over here, if I move that vertical line over, it still only hits 1 point. So, I'm going to show you a graph. Here's a graph. You don't see that very often because it's not a function. If it's a function, it'll pass the vertical line test. This fails it. Right there, that input of, let's say, 8, it hits at like 5 and 7 and 8. You know, 8, 5, 8, 7, and 8, 8. That failed the vertical line test. That's not a function. Now, 2 dots that are graphed like this, those pass the vertical line test. A vertical line will only go through it once. Yes, question?
So when you graph a circle, is it not a function?
A circle is not a function. Yep. Yes?
But even if something does pass the vertical line test, it doesn't necessarily mean it's a function, right?
False. If it passes the vertical line test, it is a function.
Even if it has no consistent, like, pattern?
So the consistent pattern part is, if I put in, remember the consistent part was, if I put in an input, like a penny, I gave that example. If I put in a penny, I have to always get out a quarter. That's consistent. Even if I also put in a dime and I get a quarter out, as long as every time I put in a dime, I also get a quarter, that's consistent. So I know you think that what you're saying is giving it an incorrect answer to my thing, but it's true. If you can draw a vertical line test through this thing, like here, I'll give you another one that's like strange shaped. Can I put a vertical line test on this and it'll never touch twice? Yeah, that passes a vertical line test. That's a function.
So even if it's like,
Why don't you draw one that you don't think would work, and I'll come back and look at it. All right, so as soon as though I go like this, they're not a function anymore. Why? Doesn't pass the vertical line test. So if you're confused by some points, graph your points. If they give you a bunch of points and you're like, I can't tell if it's a function or not, graph them. And if your points are like all over the place like this, it's fine. It passed the vertical line test because the line could have been going through it like this. But if your dots ever are exactly over the top of each other, like that, that would fail the vertical line test because I can go through 2 spots. That means one input down here on the x-axis, like say x was 0, had 2 different outputs. So the vertical line test is, if you can draw a vertical line test through it and it never touches twice, then that's a function. So last, function or not?
Yeah.
Yep. Function or not?
No.
Nope. Function or not?
Yep.
Yep. Function or not?
Yep.
Yep. If you can draw a vertical line through it and only touches once. Because that, every time you're drawing a vertical line, you're saying, oh, the input was right here. Let's say this was like 6. The input was 6. How many outputs did I have? Only that one. If it happened to have gone like this, then it wouldn't have been a function because I have 2 outputs for this one input. Okay? There. Now you learned something about functions. Okay, so what's your homework? Well, there is normally looking homework, but I am instead giving you a Schoology quiz which you'll want to grab some scratch paper, or you could totally split screen if you're capable. On your split screen, you could have one side be like your smart notebook where you could draw, but you're going to need to be, for the Schoology quiz, you're going to have to draw. You have to draw it out. There's no way you can just do it in your head, okay? So you want to draw out this little Venn diagram that I described in the Schoology quiz, and then you got to answer the questions, okay? So I made your homework a little different this time, Schoology quiz, just to shake it up a little bit. And I'm also going to release those 3 one-question quizzes. One's on midpoint. Hopefully by now you've learned it. One's on solving hard factoring problems. We just practiced it today, so it should be fresh in your mind. And Ava's got a question.
When's the lab due?
The lab isn't due until after the test. So you have a week and a day to get the lab done. My wife would have been the person who would have been like, I'm going to get it done tomorrow. And then I don't have to think about it anymore. Most of you guys would have just hated my wife for that because, you know, most of you are going to be putting it off until whenever it's due. And then that night, you'll stay up and get it done. Okay, well, you'd thank yourself if you got it done earlier. Just walk around, ask the kids some questions, get 3 circles. Don't agonize over this and make it like some amazing, 5-hour thing it's not supposed to be. The total you're supposed to spend on a lab should be an hour at the most, unless it's a really bad lab, really hard one. The most you'd ever spend is an hour. And this one, I swear, you can get it done in 20 minutes. Whole lab, start to finish, as long as you didn't agonize over which question you were going to ask, as long as you didn't try to ask 8 million people. I will say the absolute minimum number of people you can ask is 10. You gotta at least ask 10 people to answer your little question. So you're in a target-rich environment here. They all have to do this lab too, right? So walk around the room and just say, what do you like better, pizza or, Taco Bell or Chipotle? And, whatever's interesting to you, these kids will probably answer, and in turn you can answer theirs. Yes?
Can it be people outside of this class?
Yes, absolutely. It could be family members, it could be friends, it could be somebody around the lunch table. All right, so I am the Venn diagram problems is the Schoology quiz. I'm making sure it's enabled right now, so there you can start that. But a reminder, you get 2 tries and you get the average score. So that means try on the first try. I know you'll get the answers at the end and you get a second try, but you get the average of the 2 scores. So you don't just put in crap answers and then figure you'll get a better score later, because if you get a 0 and a 10, it averages a 5. That is pretty bad. All right, so 3 one-question Schoology quizzes
You have to submit the notes when you're done.
and Venn diagram. Nothing of today's has to be submitted, except for the Schoology quizzes.
Okay.
And that's all I have for you for today.